Hi there everyone, welcome back to Cody's Lab. So I'm just cleaning up from my activated charcoal project, and I thought I would use this opportunity to show you guys how I would get the iodine back off of the charcoal, and that process would reactivate the charcoal. The first thing you'll notice is that the charcoal has actually absorbed a little bit more iodine. You can see, maybe if I zoom in a little bit, that the cotton ball is brown up at the top but clear down here. So the charcoal did have some absorbing capability left, and I see the same thing with the commercial activated charcoal, so maybe I should have left it in longer. You'll also notice that I still have some liquid left in the top of these test tubes and not the one for the charcoal that I activated, and that was because I messed up on the titration and I had to get a second sample. So the first thing I need to do to get the iodine out of the charcoal is to pull this cotton ball out of the test tube, which I'll do using this little sink declogger here. So there's our charcoal without any seal on top of it. In case you're wondering, the charcoal, if you used enough of it, could in fact absorb all of the iodine, but I had done quite a bit of testing, as you can see here, to determine how much iodine I would need so that the gram of charcoal would not absorb it all, at least in 12 hours. So now that I've gotten the cotton ball out, I can add in some water to flush the alcohol and any residual salts that may be present. Just like that. Let's let that settle. Probably not need to go all the way. I'm just going to dump off the water and then rinse it a couple of times. So one thing that people were asking that I kind of wrote down was, why wouldn't just grinding the charcoal to a fine powder activate it? Well, there's two reasons. One, it would in fact increase its surface area, and you could activate it that way, but it would be so fine of a powder at that point that it'd pretty much be a contaminant on its own. It'd be very difficult to work with. And the second reason is the original charcoal. It has oils and tar. Well, if you grind it up into a fine powder, those oils and tar aren't going anywhere. They're just going to get smeared out over the rest of the particles. So you really got to get rid of it in order to make the activated carbon. So if you took the stuff that I heated up to a high temperature and then ground that up, maybe you could do it that way. So now that I've got this rinsed a little bit, I'm going to add some sodium hydroxide. Now what the sodium hydroxide is going to do is bind to the iodine more strongly than the charcoal does. So the iodine reacts with the sodium hydroxide to form sodium iodide, which is a ionic bond. Now ionic bonds are a lot stronger than the van der Waals forces that are binding the iodine to the charcoal. It's kind of like if you take some tape representing the charcoal and you stick some copper shot to it representing the iodine, and then use stronger tape to pull the shot off of the weaker tape. One other way that I've seen that a lot of other channels on YouTube have done is chemical activation using calcium chloride primarily. I have not seen anyone do it right though. What you're supposed to do is add the calcium chloride to the wood pulp or sawdust that you're making the charcoal out of. The calcium will soak into that, and then when you char it, it'll hold open the pores a little bit more. It's not as good of a way to activate it, but you can do it that way. And like I said, I haven't seen anyone on YouTube do it right. At least not yet. So let me mix this a little. So now I should have a solution of sodium iodide here. So now I'm going to take a pipette and a cotton ball. I'm going to try to transfer some of this solution. I also saw some people wondering if the charcoal was denser after the activation because maybe it absorbed some of the steam and was still a little bit wet. Well, I did turn off the steam at about 700 Celsius, so it shouldn't have formed any liquid water. Also, when I run the charcoal back through the screen, I can see that a lot more pieces go through that wouldn't have before. So the charcoal did actually shrink. There we go. Let's pull that cotton ball off there. Perfect. And transfer it over to this little test tube. There. I'll zoom in on that so we can see what's going on there. Now I'm going to neutralize the sodium hydroxide with some hydrochloric acid. You can see a slight brown color formed. And now to oxidize the iodine into elemental form, we can use some hydrogen peroxide. There we are. There's our iodine in solution. And it might crystallize and precipitate out, or it might not. I find it's pretty iffy. So now another question a lot of people had was why I didn't use starch as an indicator for the titration, because starch darkens on contact with elemental iodine. And well, in previous runs I did actually use starch, but I had decided that it was not really all that necessary. I could stop the titration at the same point whether I was using the indicator or not, as iodine itself is an indicator. And I do try to simplify my videos as much as possible. So you can see, this gets much darker. So if you have trouble seeing the iodine, maybe the starch could work. But really, I wasn't worried too much about it being exact either. So yeah. Now if I rinse this charcoal a little bit with some pure water to get rid of the sodium hydroxide and the iodide, I should have charcoal reactivated, ready to absorb more iodine. Now of course, if you're absorbing other things with the charcoal, the process will be similar, although you might use different chemicals or a different process. Perhaps heat could be used for some things if you're using the charcoal to absorb oil, for instance. So anyway, hope you enjoyed. I'll see you next time.